This video covers my solution for lesson 35 homework on Paul Mcwhorter's Raspberry Pi series on YouTube. Now you notice when the program starts, it comes up, it says that it's waiting for the PIR to adjust. Most people claim that it takes about 10 seconds. And notice that it comes up in the arm state. So if I cause it to sense motion, it senses motion, but it doesn't do anything right away. Just in case I was wanting to return and disarm it. Well, I didn't disarm it, so now you see the LED flashing, which is my silent alarm. Now if I come home and find it's on and I want to disable that, I can enter the command to disarm it, and it asks for a password. My password is 1, 2, 3, enter. And it turned it off. If I arm it again, I don't need a password in this system. It's armed, but I have time to leave the premises. After 10 seconds, in this case, the system is armed, and if there's an intruder, the intruder will be detected. So if I cause motion to be detected, which I just did, after 10 seconds, the LED should start flashing. So let's disarm it again. B is the command, and asks for password 1, 2, 3, enter, and it turned it off. Now let's suppose I arm it. I leave the premises, and I'm gone for some time. So now the system is armed. Let's say later I come back, and when I come back, it detects motion. But before it can turn on the alarm, I can disarm it. It asks for a password, 1, 2, 3. Well, I didn't quite get it done quickly enough. I guess I need more than 10 seconds. But at any rate, the other functions of the code I covered in the previous video, so I'm not going to go over all of those again. This code is for lesson 35 homework for Paul Mcwhorter's Raspberry Pi tutorials. If we look at the first section of code, this is merely used to set up the hardware and the libraries that Paul covered in his tutorial. This other set of code is used to initialize variables. Now one of the variables, the last one, is called setup delay. This is used so that the person using the system can either enter or exit the premises without setting off an alarm. I have it for development work to have a delay of 10, but in real life it's probably much longer. It would be much longer than that. If we scroll down to the beginning of the program, the first thing we do is to shut off the alarm. We don't want the program starting with the alarm running. Then we write out a message that the PIR has to adjust the time, or needs time to adjust, and it sleeps for 10 seconds. After the 10 seconds, it displays a message to input a command and tells the user that the system is armed. Then we have 3 sets of code here that are used to initialize threads. The top one we covered in the last video, which is the getKeypad thread. And the name of the function is getKeypadString. The other 2, the next one is the checkForIntruder function. We call it checkForMotionThread, and we get it started. And we do the same thing for the alarm function, the alarm thread, and start it. When we get down into the main loop, we first look to see if it's in the arm state. If it is, we read from the PIR. Now this variable motion is what the PIR returns. It will return either a 0 or a 1. A 0 means there is no motion. A 1 means it has detected motion. Then we look to see if the keypad has returned, or the keypad thread has returned a string. If it has, the string needs to be a command, either A, B, or C. And if it's an A, there's no need to arm the system if it's already armed, but if it's not armed, we go to the arm function. If we say disarm it, if it's armed, well, then we can disarm it. If it's already disarmed, nothing is done. If it's a C, it has to be in the disarm state, and then we go out and change the password. If it's none of those, we make sure that the input command message is displayed on the LCD. If we go back up and look at the new functions that we set up as threads, this one is checkForIntruder. It looks to see if we're in the arm state in this loop. If we are in the arm state, then we look to see if the motion has been detected and the motion state is 0. We use the motion state to see if I've already done this before. If not, this gives the user time to either enter or exit the premises so that the system can be disarmed. Then after the delay, we set the motion state to 1 and the alarm state to 1. If it's not in the arm state, we make sure that the alarm state is 0 and the motion state is 1. Then if we go up to the alarm function, the alarm function looks to see if the alarm state is 1. If it is, it turns on the alarm. In this case, we're using a silent alarm, which is an LED for developmental purposes. It stays on for a half a second, turns off, and stays off for a half a second. So as long as it's in the alarm state, the LED will blink. If it's not in the alarm state, it makes sure that the LED is turned off. The other functions we covered in the previous video, so I won't go into detail on those. With one exception is when they arm it, I let them know that they have so much time to exit or so much time to disarm the system. Oh, there is one more change. When they change the password, I briefly, for 2 seconds, write out the new password, followed by the string new password. And the system then goes back to input command message.